Welcome, I'm Bill Wake. We're here working on a word game called B-Twist, and we're working today on the Trie, which is a way to implement a fast search and partial search, or search for words that extend this one. And we're going to see what we can do. We've made something that can take the data structure and find things in it, but we haven't done anything to actually populate the data structure, so we're working on that. All right, and we left off, we started with, well, an empty list makes an empty trie. That's pretty trivial. We got stuck on this next one, and I think I've been in my mind taking a bigger step than maybe this deserves, and so we'll slow it down a touch. I do think we're going to have to do some changes in our data structure, and that makes me wonder if we should have sort of a build time data structure and a runtime data structure. We'll see what happens in a minute here. It should crash. It's where we were yesterday anyway. I don't know what these all are. New messages, so something's funny. All right, we're still launching. All right. Should be faster than yesterday anyway. Okay, there's our crash. So what we got is we're not actually putting anything in our trie.next. So next sub-zero doesn't exist. All right. Let me just do a quick review on the data structure in case you weren't here yesterday. The basic node is like this. It's got a flag that tells us, does this terminate a word? And then it's got a list of the next characters and what trie should interpret those. So here you can see we start in this state with false, and we've got some words that start with B and some that start with A. The word B, E gets you here, so we work one letter at a time down the tree, and B is a word. It's got true here. Or you can keep going and go to bed or bet. Now A, we haven't honored the word A here. It's false, but if you do the S, you get to as. No, you get to as. Okay, and so our data structure basically is this. And let's see. Now, here's try. Let me close this one. We started to build a separate project and said, no, let's just do it in our main project and see how it goes. Okay, so add word does nothing. Right. So at this point, when you say add word, we just ignore it. And so you have no words in your empty trie, and that's the way it goes. All right. So what we're trying to do is make this variable hold the trie that we're building, and then at the end you ask for make. So you call add. I think this is maybe a private function. We haven't needed to expose that, I don't think. But you call add, it runs through the list of words, adds each one, and then eventually you call make, and you get the resulting trie back. All right, now let me just say the problem I'm seeing. We've got these things as constants, and in the production use, the runtime use to look up words, that's kind of how we want it. But now we're saying, oh, I want to add a character to this next option, and that's not going to work. Okay, so in our case, I'm going to do a stupid solution that will not work. At least I don't think it will. Okay, so if we take your word, I think we want to kind of be like our other implementation. So let's word of string. Okay, let's let value equal array of word. Okay, that gives us an array of character, which is pretty handy because that's the kind of things, I guess string.element is character. So that'll help us when we're building the next up because it needs characters. All right. And then what I'd like to do is I want to get an A to a node that looks like this T with nothing in it. Okay, so I could append A and this empty word thing and that would be sufficient. But I think it's going to blow up when I try it. So, or compile time error. So I want to say try.next.append, and then the element is a character. Let's do value sub 0. And, well, we haven't checked for null, but that's okay. To a trie, and the trie we want, well, we don't have a static instance. But I'm going to make one static let end word equal try sub is word true, next empty. Okay, that seems right. Okay, so we can reference this. Oops, down here. All right, so I want to append try.endWord. Okay, which is really the end of a chain of words, because I can have intermediate words, but eventually I get to the last letter of, or the longest letter in this chain. So BED forms a chain, BET forms a chain is the way I'm thinking of it. Okay, right. Cannot use mutating value. Next is a let constant. Okay, so that, I don't know. Also feeding into my thoughts here is I'd like to be able to count things as an optimization to know, like I want to move the letter that comes first in this list of words should be the one with the most words under it. So B has 3 words, A only has 1. So I'd rather search B before I search A. Okay, so I have a use for more stuff than I want in my production one. Let's, oh golly. Well, I could make them var. Let's get out of red. We've been there 21 and a half hours now, so okay. That is mark method mutating. Yes, that's true. Okay. Add word. Right, everything is now mutating for these, except make is not, because it's fetching from here. Okay. Well, let's run those tests again. I'm not sure what happened there. Cannot use mutating method member on an immutable value. Function call returns. Oh, yeah. Ugh. So my nice little chained function call, I forget the term for that, but it's kind of, when you use a builder that you make something like this, it really it really makes it nice to read, even though this is sometimes kind of a painful, dangerous thing. Let me change. Let's change our builder. Yeah, we may come back to that one. Let's make it a class. The search is because we're using a list of character and try here, you're searching forward through the list till you find the matching letter. Okay, but once you do, you're going down. I could I could have an array of 26 letters, but that takes up even more space, and so it's kind of it's a trade-off, basically a space trade-off to kind of squeeze it a little bit. We could do a binary search, but I think you're just not going to have enough values in this list typically to matter for a binary search. I guess the vowels might, but most consonants just don't have that many consonants that can follow them. So, yeah, it's a slight bit of searching. But going down, there's no choice. You have to find the right letter and go down. Okay. All right. Mutating is no valid. Yeah. Okay. Take it off there. All right. Now I'm hoping that. Okay. Yeah, that should solve that. Yeah, and I should say a given letter will only occur once in this list, so there won't be any ambiguity about which branch to take. Okay, and that's good, and it passed. Okay. Well, I think making this a class is a good move because this thing wants to accumulate state, and that's what classes are good for, and it wants to mutate because it's building that structure. So you could do it without a class, but I think it'll be the easiest way for now. Now this one, making this a var. Oh. Yeah, we could look at making it a map or dictionary type thing. I think let's get it implemented, and then we'll tweak on that stuff. Okay. Right. So what we've done with AdWord is we really only handled the case of one word. Now I don't know if I can generalize it a little bit. And I think maybe putting end word is kind of funny. Let me make an empty one too. Whoa. Okay, and let's make this be. I think he should use try.empty, and then he should say try.next.last bang dot 0 equals true. Not the best. Can I say .isWord? IsWord equals true. Cannot assign to property. Last is again only property. Value of tuple. Why are you? Oh, that's my tuple there. No, I'm doing the wrong thing. Let's extract this. No. I'll say last try. Okay. Now, why is last a read-only property? Well, what I want to say is last try dot is word equals true. Okay, because when we get to the end of a word, we want to make that last node be true. Now, is that not going to complain? Of course it is. Cannot assign is word is a let constant. Okay, let to var. So now I'm making the other field a var as well. All right, is that the only problem? Cannot assign to property. Last try is a let. Oh, that's fine. I want him to be a var anyway. Okay. So what I'm trying to do is kind of break apart even the simple assignment and kind of bend it towards what it needs to be in the long run. So, well, expectation failed. Try.0.1.is word. Okay. It's because these are value constants. That's going to be tricky. Yeah. See, this last try is a struct. So this is a value. We put the value in the list. You can't alter it if it's a struct. So again, I think you don't have the information in the build process until you get to the end of the word. Do you know that you're at the end of the word and you should make that last node a try? So let me I'm going to go backwards. Okay, this, I think we'll accept that. Our constructor does what it needs to. I'm going to put these back as lets. Okay, I'm going to introduce a try node. He's not a struct. He's going to be a class. I think that can go. And then this. Now, this is the thing we're building. It's not the thing we're searching. Okay. So we will have to do a step to convert this to a try. So I don't know if that's really... I don't know if that's really going to work. Okay, let me get this. I think those are only used by the builder at this point, so we'll keep them here. This is TrieNode. TrieNode has no initializers. Why is he not getting an implicit one? Okay, we'll take the generated one. All right, now this thing needs to be TrieNode.empty, append him, and then cannot use mutating. Remember, next is a let constant. Try, oh, this needs to be a TrieNode. Okay. Tuple type character yeah. TrieNode here. I don't know. Okay. cannot return that. Yeah, we got to turn it into the other. I'm not sure. Given the simple test we have now, it shouldn't matter, but so I think in general it's going to be difficult, right? Because if this is a struct, these are immutable things. Well, because I made them let, I can't even mutate them. Which fits the runtime aspect of looking things up, so that seems okay. But if I'm building these things, right, I'm gonna have the first word come in, and then the second word comes in. It's gonna add new nodes, and then it's gonna have children, and some of those children, like I might have had the word bet and then had the word be. So I got BET, but this one's not going to be a true. It's going to start out a false, So at some point I would realize like, oh, now this word's shorter than another word. It should, it should change the flag on this one, even though it's supposedly an existing constant. So I don't totally know. This should be TrieNode. Okay, and then the question is, how do you make one of these under this new regimen? You'd have to copy the struct and add it to the tree. Yeah, but then the tree, like the middle of that tree, right, is going to be another const. I don't know. It's like the whole. You'd have to add it to the. I'm worried you'd have to add all the way to the top, which seems excessive, but. Okay, now how do you convert a TrieNode to a trie? It's tricky because you have to get down to the leaves and build it bottom up. All right. But the thing is, everybody's values are constant because we're calling make, which is the end of the line. So there won't be any more added words, or if they are, we regenerate it, Yeah, it's not going to be tricky to do it recursively, I don't think, but it's a lot to ask of one little test there. Okay, so the trick is we have to work bottom up because this thing needs constants going in because it only gets one chance to assign it. So if you do top down and you realize, oh, I got another array in my list, that's not going to cut it. Okay, so if you have a TrieNode, all right, it's pretty clear that to do this TrieNode, we're going to say you need to build a list of these things first and then assign it once. Okay, so the way to do a node. Hey Tooks, welcome. We're working on this word game. I don't know if I have it running. So it's kind of word searchy kind of thing. The board actually duplicates, and I think I'm going to put my view in that shows that again. But you're trying to find the longest words you can. And I don't know what this little extra white area up top is. Something's a little funny, but at any rate, when you find a word, if there's a shorter word contained in it, it gives you that as well. And then we're also trying to do something where the system can tell you all the words it found. And we have the code that actually goes out and finds them, but it doesn't perform fast enough. So we're working on this new data structure called a trie. It's sort of a tree of words. Oh, yeah. Are you the real Tooks? Okay, so we're having this tree and we're trying to build this tree back up. Just the short version. Okay, so the result of this try is going to be it's going to be a new try. Is word is well, it's going to be try.isWord, and next is going to be, I'm going to say make list of try.next. I don't know. Okay, and make list is not defined. I think I need to pull this out a level. Okay, but make list. Takes a list, generates a list of tries. That's great. Thank you. Xcode. All right. So the way to do this is to take the list, and we're going to map each one to. Yeah, I need a make that takes a tree. Oh. All right. Okay, so each one of these pairs, it's going to map to well, yeah, it's got character and node in something in some path. Well, we have to map each pair of these to a pair of the character and make of node. Yeah. And this is file private. And this is make node. Well, make with node. So this should just be make of try. And this is node.isWord and node.next. Okay, I think that's... Yeah, we pretty much finished that, or I got it to a point, I'd say. That was always kind of a personal project, so I didn't try getting far enough to publish it. But I'd like to get this one in the App Store eventually, if I can get it up to what I want. Which we're getting there. It's coming along. I'm not sure the mix of letters I have is quite good enough yet, and I think the approach we use to generate them just doesn't quite capture English patterns or something. All right. Yeah. Okay. So how do you map a try node to a try? Well, you copy the flag and then you make a list out of all its nodes and use that to build up the try. How do you make a list from a list of character and try nodes? Well, you map the pair to a character and making whatever the node is that's in the try node. Okay. Well, if you want to send me your email, and anybody that's watching, send me your email, and I will get you on the beta test list for it. I've released it once to my brothers, and I can include you too. I'm Bill at xp123.com will get it to me. Okay. But anyway, I think this map is correct. I mean, this is relatively simple as recursive little functions go. So let's see if this is back to working. Oh, you'll have to email me. I can't see it. It cancels out your stuff. Okay. Last try was never mutated. Now that's different. Okay. Good. All right. So I don't know if this is going to be a good move or a bad move, but we've developed this now using a class with a node, and it's going to create a struct without vars. They're all lets. Okay, so it's and this, if this were a separate app, the builder, we started going down that path and pulled it in because it's kind of simpler to keep it all in one project. We wouldn't care so much. But I think that the trick is the JSON import is going to be a little ugly. We have to do it by hand because we've got something recursive, and I'm not sure that can be done. All right. So I think we're ready to move to a new test. Not that test. That looks too hard. Let's extend. Okay, build from 2 letters. Okay, and I'm going to add them in the backwards order to kind of demonstrate that works, as well as adding them. So if I add AS and A, that's kind of like the right side of the tree, but I want if you ignore the B side of the tree, this should look like this after the first word when we add AS. So it should add an A node and an S in here. And then when it comes to the second letter, it adds the S node. And then when we come back in with just A, it finds it already there, but it's got to change this flag. So that's why it's got to be variable and more of a class. Okay. But you know what? I think maybe that's too hard. Golly. I think this will capture something. Okay. So we expect the try. So if we make this, the top level one is not a word. That never is. Okay. The next count should be 1. Next 0 should be A. Is word should be false. Okay. And then next sub 0.1.next, that's the second one here. This should be A. Next sub 0 equals S. Sorry, not A. Okay. Next sub 0.0. Wandering around through these structures is not so fun. And try sub next sub 0.1.next sub 0.1 dot is word should be true. Okay, so A is not a word, but AS is a word, is the gist of that. And this test will fail because there is no next of 0.1.next of 0. So this first access down here should blow up. good, I think. Let's see if it's in the right place. Yeah, okay. So go back here, and now when you make a word, okay, I do want to keep that value there. The last try, well, it's the try that we're trying to extend. Okay, so I want to say, well, here I'm doing value sub 0. I want to change this to be letters. For letter in value. Okay, and so I'm going to start last try is our top level thing. And then I don't know what this is doing. I want to extend the last word, the last node. Let's make this new try. And then I have to move try forward. Yeah, for me, nobody's paying me to do this stuff, so I get to choose what I want to fool with. Yeah, I mean, UI Kit's, it's got things that it still can do that Swift UI can't do very easily. So, yeah, and you can move between them. There's a class on each side, one that a UI Kit class that lets you run Swift UI things inside, and a Swift UI struct that lets you, or view that lets you run UI Kit inside. So I bet you find lots of projects have both these days. Okay, so now I'm trying to go letter by letter through the word. So I start at the top try. I'm going to make a new node that's empty, and I'm going to append a new value there. Well, that's not going to be quite right. I think this will get us through the A's, but not through the as's. This should be letter. Okay, so I'm making a new try, and I'm going to move on down. Now this making, it shouldn't make it if it's already in there. So that's the gap I'm not handling yet. Okay, but let's just make sure we go through the word. Okay, we're going through the whole word. We're keeping track of the node, the last node we added anything to, which starts at the top node. We'll make a new node, append the new node with the letters. So if it's A, that gets appended. A goes to the new node. Then try now points to the node we just added. And again, it's a class now, so that's going to be reasonable. Last try. Thank you. Yeah, that name try is going to kill me, because do I say it there? Yeah. Maybe I should flip these. This is the built try in progress. Well, that didn't do it. Root. Maybe even just root by itself might be good enough. Okay. And then I can use try in here, which I think reads more naturally. And it's what I want to type anyway, so I kind of have to do something. Okay, so we start at the root. That sounds better already. I love that. Thank you. For each letter, we build a new node corresponding to moving further down. We append that with the letter, so we're moving down a level, and then we go down the level to the new thing. So we have our A, and next time we add, we're going to add to try, which is now the node with the A in it, and we'll create a new child. Okay, this may work because we took out the 2 word thing. It doesn't handle 2 words. It only handles 1 word, but maybe we're doing arbitrarily long words now, which would be nice. Yeah, I guess it was never mutated. It is mutated the next time through the loop. Okay. Oh no, are you going to blow up on me? Oh. Bad access. Huh. And that looks like a very, very deep recursion. Something didn't get updated somewhere. Okay. So let's run this with debugger going. All right, so when I go through the loop, I should be able to look at root, and it should reflect what we want. Okay, so I'm going to step over. All right, now if I print root, okay, he is not a word. He's got one next value, which is A, and it goes to something that is not a word and has an empty thing. Okay, that seems correct so far. Maybe it's my recursive thing that's not so good. All right, now let's go back around. And if we print root, he should look the same. He should now have an S in that inner one and be pointing to a is word false still. Okay, it's looking promising. Yeah, there's A, there's the S, and 2780. Oh, he needs to make a new one every time. Yeah. Yeah, so see the addresses, excuse me, that end in B7C80. So because the empty node always has that there. So well, maybe this is just better to do. I gotta make my own. I don't think I reference this anymore. I don't think I reference this either. Nope. Okay. And that's why that print was having, or the make was having so much trouble, because it got stuck in a recursive loop. Okay, let's try again. This is the cost of before I had value objects, and so I could just copy them in, no problem. But now I'm manipulating them, so it's more work. Okay, good. Now, I want to make let me expect try dot contains and prefixes. Now let's do a different test. Okay. A tree handles a large word. Let's make this asking. Okay. And now I want to say let search result equals try dot contains and prefixes asking. Is word should be true, and is proper prefix should be false, because there's no longer word defined. And then let's do another expect. No, let me rename this one. Search result 1. I don't know. I think I'll just do it that way. Okay, so we'll get partway down, but we expect search result 2 dot is word to be false because we didn't put that word in there. And is proper should be false as well. Okay. And I think I'm going to ask one more question of it. All right, let's do this. I don't know, maybe this should be 3 tests, but they definitely share a context. Let's put a partial word in, longer than 1 letter. And this should be not a word. And is a proper prefix should be true because it is a prefix of a word. Okay. And this is the kind of test I expect to pass the first time. I call it confirmatory or confirming. It's supposedly I already know it's going to work. If in fact it always worked that way, it would be good, but it doesn't. But I'd like to get things to a certain point, especially recursive functions. For some reason, I'll try little things on them to make sure each piece of the recursion works, and then I want to try one big complicated case. Okay, like this. Is word false? Try has asking, contains and prefixes asking. Is the word asking a word? Okay, let's break again. I guess I want to get down here and see what the root looks like. Hopefully it's a big long change. A to S to K to I to N to G. He doesn't want to show me the rest, or he doesn't have it. This is the first test. No, I think I ran this one directly. What I can't tell is if he's doing ... to say I don't want to show all that stuff, or how can I tell? Yeah, notice this is different, 25760, so there is another one out there. Yeah, it kind of does, but this one was an empty one in the end, and I don't know, it maybe change the AS test. Well, we know he's not even running, right? Because I just did this one. We can check the word on the way in if I get there in time. Better be asking. Okay. Yeah, we're on the right one. That's the good news. Bad news is, okay, next, we're appending. Well, I guess if I go through this loop, I should see it acting on A, S, K, I, etc. Okay. I don't know if I have letter yet. Yeah. I'll continue. Okay, fine. Okay, there's my A. Well, I'll continue. This is the S, the K, the I. Okay. I'm going to continue. And okay, so that structure should be good. We'll print try. Okay, yeah, so he's a word terminator. 228780. It's so long I can't get there. I don't want to trace down through 6 layers of code of tree structure. So is this a problem? Well, it didn't find answer, but it did find proper prefix false. I guess the problem I have is I don't really know if it's my builder or my contains in prefixes that has the problem. Or it could be the way I build them doesn't quite, like, something goes wrong. Okay, so if I map an empty list, then I get an empty list. Well, let's let me simplify this test. So if I search for as and ask, okay, let's try this one again. It's small enough I can maybe get through the search should be fine because we convert, right? Our make converts it to the original try structure that has the search on it. So assuming we built it right and assuming it converted right, theoretically this thing should work. But, you know, what's that worth? Okay, so now I should be able to look at root. I don't know if it'll show me more because it's smaller. No, it won't. Okay. Well, I can go through root dot next sub 0 dot next sub 0 dot next sub 0 dot 0. What would be the next sub 0 is, I gotta put my dot zeros in there, don't I? Next sub 0 is the tuple, so I gotta do, oh wait. Next sub 0 dot 0 is the A, dot 1 is the next. 1. Ugh. Sorry. Get some visibility here. Okay, so root dot next sub 0 gives me this list. Root dot next sub 0 gives me this tuple. Dot 1 gives me its inner value. Dot next sub 0 dot 1 dot next dot 0. Okay. Okay. So I'm down 3 levels, and that's fine. And then if instead of 0 I ask dot 1 dot next sub 0 dot is word. No, he doesn't like that. Next sub 0 dot 1 dot next sub 0. Next sub 0 is a tuple. Dot 0 is the letter. Dot 1 dot is word. We don't need an end word class. I think that I got rid of. So the TrieNode doesn't have it. Does this? No. It's gone. Index on a range. Okay, let me go back to the one that was the K. This. One. See if that. Okay, is word false. Okay, so yeah, the very last one. I mean, this looks right to me for what it's worth. Okay, so let's take a break at this. Yeah, let's break, well, back in the test. Okay, let's stop here, and this should tell us, we should be able to look at it and see if kind of the same process, if he's structured right as a trie, and then we'll go into contains and prefixes and see. I don't know. I don't like debugging too much, but continue. All right, now let's print the trie. He'll only give us 2 levels. There's the A, there's the S. If I do this again, yeah, we have a terminating node. It's true and false. I can't even pronounce it. QEQ PEP0. We're working on this retrieval tree. It basically works its way down with the prefixes of something, and we put in a long word. We're only partway through constructing it, but we put in a long word which we thought would work for searching, but it's not. So we're trying to figure out, did we build it up as a temporary structure and then we convert it to the proper structure? And so we're trying to find it. It looks like it built the right structure. Now we're checking the conversion, and then we'll check the search. Okay, so this should be back to a trailing node that has a true and no entries in its next. Good. Okay, and if I go back a level, we get the K. Okay, so we put the word ASK in. Its child is this leaf node. No, we're converting. We've got a very similar structure that's a class, and we're converting it to the structure that's a struct. And but that seems to be okay. I mean, at the end of it, the front of it looks good and the end of it looks good, so I'm going to assume it's kind of okay. It builds up, multiple letters. So we're doing ASK, but it's sort of like BED. All right, so it's got these 4 nodes involved. That's for another word, but the last node has to be a true. In our case, this should be a false, and that should be a false, which I think, yeah, this one is false coming in. So that seems okay to me. Now, we don't know if this one will fail yet. Let's make sure this passes. I don't know if that's the old message or not. Okay, no, it's not. Okay, so yeah, we're converting a list of words to a trie, and right now our list of words consists of 1 3-letter word, and it's not succeeding its test. So, okay, so the trie looked okay to me before and after conversion, and when we ask, is the word ask in this trie that only handles the word ask, he says no. The word, it's not found as a word, it's not found as a prefix of another word. Now the second one, that's correct. And then this one, it's not a prefix. Yeah, sorry. All right, but I think, well, I don't know. One thing I could do would be put a better debug description on these things so they print in some more tree-like way, I guess. But this is kind of weird. Let me make sure this is. Okay, yeah, so the class structure is basically the same stuff. It's the flag and the list of character to tries. We do it this way with a class, so it's all mutable. But in the long run, for the game lookup, I want that to be working off this immutable structure. Now, it may be it's too much trouble to maintain both, but I don't know. But it seems right to me. What we saw for ASK looked right to me, so I'm not sure why the search would have problems with it. Okay, but we're going to break there next. Okay, we'll stop here and then we'll break inside there. Okay, so let's run this again. Part of the reason one reason I do it is because I need it mutable for building the structure from multiple words coming in it, separately. And then the other is that I think I'm going to put some statistics on the building side, and that may be being separate. Okay, where are we? Okay, so we are ready to do our search, and that should continue here. Good. Okay. The target should look like ASK with characters. Okay. And let's look at the tree or self. Okay, so he starts off with A. A is not a word by itself. He goes to S and so on. Okay. Step over. Okay, there's the A. Make sure node was found. Yeah. Okay. Node is nil. No. Okay. The try is node.1. Okay, so let's look at the try. Okay, now the try, the A is gone, so we're one level down. Is word false, goes to K. Oh, boom. Node is nil. I don't know if I can still see CH. No. Okay. Now, why did that not find the S? Maybe it's jumped ahead of itself. Not saying anything other than my code is wrong, but I thought we checked some modest words. Maybe not. Okay, so I think I can take this one out because I'm already breaking at the other. Oh. Where's next coming from in search? Yeah. Next. Oh. That's off the try we're on. But should it be try dot first? I bet it should. Right, because otherwise this is almost like the root, and then we're inside here. Yeah, you're right. Good call. Good catch. Yeah, let's break out of here and change that. Yeah, I mean, try is the thing we're looping over. That's right. Is that try dot next? So the first time through, he is the same as this next, but the second time through, hopefully he's more on the node we're on. Okay, let's try that test again. And it's funny, this is kind of one of these things from it's a mistake I'm making, kind of iterating through, where it would be very natural to do a recursive search. You could do a recursive search, but it's kind of tail recursive in a way, so it's kind of reasonable to translate it into a loop like this, but you do pay that price. Okay, so that's good. Let's run all those tests. I'll put this back to asking the original form of the test. Oh, well, thank you. I never quite know if I'm getting buried. You know, you walk in the middle of something, it's tough. Okay, so if it's doing things right, it should be able to handle a long word, asking, longish, not find it when it's not there, but find a prefix and know that it's a prefix when it is there. I think this almost, I think in terms of testing, I should probably swap the names around. Okay. Now, all right, so we'll run all these tests. But this one should also work with the bigger word. Oh, thanks for subscribing. Appreciate that a lot. Okay, good. All right, now what's funny, we did have tests on this search. Is do we really only search tiny stuff? Yeah. Okay, well, a good long word is a good thing. All right. Oh. Okay, now let's go back to try this builder. Okay, let's kill all these breakpoints. Sorry. There's a way to do it up here. Yeah, now 2 words. And we know it's not going to work. Well, okay. We know it's not going to work if they overlap. Right. So, yeah, we'll do an unrelated word and see if that'll go. Okay. Builds with 2 unrelated words, or I'll say non-overlapping. Okay, so let's add asking and bet. And I think we got rid of just contains. Okay, then do we add it up here? No. Okay. And this is probably an okay format. So let's ask for bet and October. This should be false, false. Bet asking is a word, is a proper prefix? No. Bet should be a word, not a prefix of anything else. October should not be found and is not a prefix. Okay, and it's longer than these words, so if that causes a problem, that'll show up. All right, but I think our structure will work for this. Where I don't think it'll work is if we have 2 words that start with the same letter, I think we add in the letter twice and it's not going to find it. So, but we'll see. Okay. Right. So that is, well, it's another one of these kind of confirming tests that I expect to pass. So in a way I could just delete it because it's not breaking, but it'll serve as a little bit of a guardrail if something else goes funny. Okay, so now let's do the overlapping tests. And the trick with the overlapping one is we're going to put the longer word first. Builds with two overlapping words. Okay, so asking should pass and ask should pass is a word, not a proper prefix. This should be a proper prefix. Okay, and then let me search for ASCII or asking. I'm just asking. Okay, this one is not a word, so leave it, but it is a prefix because it's on its way to asking. All right, and my prediction for this, I think the word asking will go in there and be fine, and then I think the A for ask will start a new entry, and when it searches it's going to find the A for asking but not the A for ask. There'll be two entries for that, which should be unique, not duplicated first letters, I think. So I think this test will fail and this will pass, and the first one will pass is my hope. What do I know? Oh no, that is right. That failed. Okay, so is word false fails even though we put it in there. And it didn't blow up on any conversions or anything, so that suggests I'm understanding my data structure a little. All right. And where that's going to be a factor. Okay, so here we build the new tree for that letter, but we don't look to see if we need to. And if it's there, we should just use it. Okay, so we kind of need to search in there, and we do a little bit of a search here. Was this this kind of thing? So I'll kind of steal that little bit of code. Okay, so if we're in try, we're going to look at the next and say, do you have an entry with the letter already? And if the node let's make sure what node is. Is he the pair? Yeah. Okay. If node is nil, we have to do this. Well, that's not quite true. It's almost like, well, let's do this. Okay, so now the else, we've got node is not nil, and we know node.1, node bang.1. Well, make sure this type is a trie. Okay, so that's the next level down, so we'll just assign that. Okay, so if the letter's present, well, if the letter, I don't know if I should reverse these, but if the letter's not there, then we're going to create a new node for it and append that to the current next. Otherwise, it's already in the next. We're sitting on it. It's node. And we'll take that node's entry, which is already a trie. Okay, I think that's it. We will take that advice there. This data structure does lend itself to a lot of puns. Okay, let's take that. All right, now the question would be, what's does the order make it bad? Can I fold this in a... Okay, if the node is nil, I don't know if it reads any better. If the node is not nil, then move on. If it is nil, set up some stuff and then move on. But both those, I'm trying to find a way to fold it together so we just always say trie equals new trie. But we had to do an extra action there, so okay, yeah, let's try that. That one I think would have worked before. So this was two overlapping words longest first, and this is shortest first. Okay, I'm okay. The search doesn't matter which order, but that should all be okay. All right, let's make sure that should be good. That's right. Yeah. Okay. And now this one, well, words, let's make it the way we do these days. Tries TrieBuilder ask of words dot make expect trie is a word. No, we're not gonna. Let's check this at the. Let's just check that each of these is in there. Ugh. The search result was better to have both those together, but I hate what it does to this. Well, let's do words dot for each word in. Okay, I'm gonna make the search result like that. Oops. Okay, I'm not going to assert about prefixes. I'm just going to assert that you should find this word every word should be in there. And this is our example from here. So it's got a little bit of intertwining between these things. All right. Okay, so we, well, I think we put that other project in. I might want to take that back out. Add a project for setting up the dictionary, but we don't use it. Make a TrieBuilder that accepts a searchable trie. Okay. I think that's good. Now, setting up that project was not horribly hard, so hopefully tearing it out isn't hard, and if we need it again later, we can build it again. Well, let's delete everything in here first. Huh, it gets its own assets file. I didn't realize that. Where is the assets? Oh yeah, resource. Okay. No, maybe I can just do this. Delete. Do you delete everything? Yes. Move to trash. Okay. Let's do a clean. It was called Betwist Dictionary, and I put it as another project, not, is that the right word? Another target. Or, yeah, we started to use it, and then it's like, well, if we, because originally I was assuming we'd run the builder like I would run it as the developer when I had a new dictionary, generate the JSON for it, and load the JSON into the main project. But we're going to try it without that. We're just going to read in the dictionary as words, build up the thing, and then search it. When I say it that way, it sounds slow. All right. So that all seems good. Okay, so we removed the unused project. Now, unused project for building the dictionary. Okay. And I think we'll run, but the stuff we've been doing is unlikely to have had any effect on that. We don't yet build that giant list of words. We did temporarily to make sure we could find the words and everything. So that seemed good. Okay, so ally. See, this board has multiple Ys. They're different colors, so I know they're not the same piece. And actually, I see 4 different colors of Ys. So that to me is well, that's a good idea. Yeah. But anyway, these 4 colors tell me there's 4 Ys in a board of 25 letters, because there is a repeat, DOYY. O DOY. You can see it's kind of coming in. I think it's actually more in the middle. TLACP maybe. But that's a lot for one board. Okay, ally. Let's find another. I'd like to find one that was longer than, I don't have any E's. That cuts out a lot of words. W has no vowels after it. Yeah, I think the bolds. Okay, yeah, we got the two words. We can find bold it gave us for free because we guessed the longer word. All right, and we don't have a button here to show us all the words. Okay, so it's break time, so we'll take a 3 or 4 minute break. But I think the next step is kind of figuring out this new game, how it interacts with showing me the answers and all that stuff. Because for now, we can, when we read in the dictionary, we'll automatically convert it to a trie and then make it call that. I think that'll be enough of a challenge for the rest of today, probably. But I think we can kind of temporarily shim it in there instead of the binary search we use now, and see if it's at all plausible that it's going to be significantly faster. If that seems possible, then we'll go ahead and do the JSON saving and all that stuff, and go from there. All right, so break 3 or 4 minutes and see you back. Hey, welcome back. Yeah, discussion there, right? So we have a searcher that tries every word, extending every word, and then we do a binary match across the dictionary to find the word. So if you find, well, this one is so bad, but if you find bold, okay, it's going to say, oh, I can go here to S, I can go to D, I can go to O or T or P or C, and it tries to build things and extend them. We do a binary search to say, is the word in there? And we do a binary search to say, does this start a real word? So BOLD starts a real word because there's another word that's longer that starts with those letters, which is bolds. TYBY doesn't start anything, so there's no point searching longer than that. Okay. The try thing, let me find my picture from the other day, is kind of a performance thing. The first search we did was linear, and it was just unbelievably slow. No surprise. We got a 250,000 word dictionary, so it multiply that times 150,000 possible words it's finding, and it's painful. Okay, we did the binary search, which is log n search. So log of 250,000 is like 18 bits or something. This one, the try, it works its way down that data structure one letter at a time from the word. So it's only working as hard as the one step for each letter. So it's a lot smaller. Your typical word is not bigger than 18 letters, so now you can't quite, it's not quite equatable, but it's suggestive anyway. Our hope is this is fast enough faster. So this was 2.5 hours. This is like 2.5 seconds, kind of to a first degree, just to be a round function of the other one. So what is that? 3,600 times faster. 2.5 seconds is kind of, it feels kind of slow if you open this and it takes 2.5 seconds to pop up while it works out the correct words. So our fallback is kick off a separate thread that's looking for those words, but don't hold up on the UI until they're there. And then when they try and show them, they might have to wait the 2.5 seconds. If they do right away, show them. But usually you're going to come in here and do some guessing and that. So yeah, if you could do it async, would that's my fallback on this. But I thought, well, a try is kind of a fun data structure to play with, so we'll implement that. So and it has the chance that it may be, if it does it in 1/10 of a second or 1/4 of a second, I don't have to worry about it anymore, and it'll speed up, potentially other things too. So, all right. So did I check this in? Let's make sure we do. Okay, good. Now, to use this thing, let's go back to our structure. Right now we have vocabulary, and vocabulary has the binary search. Okay, and it has this contains and prefixes method. I think what I want to do, I think just to leave this around, let's kind of duplicate this, and we'll make a class vocabulary that works from, that builds up the try, and then searches with that. Okay, so if right now they call vocabulary with a bunch of words, so we're going to do that, but we're going to use our try and our TrieBuilder in particular for this, and we'll pass that list of words to it. Okay, so we will call TrieBuilder.add on that. And I don't even think I have to save the words for that purpose. TrieBuilder dot add words dot make. Okay, so that should give us a try, which I should be holding on to. Try of try. Okay, now the functions we need contains and prefixes. Okay, so our try has this method. Okay. And then what else do they need? Contains. And that's it. Okay. So now I think we've substituted it in for now. Let's run tests. I don't know if they do anything. Yeah. Per T. Is he doing dot words? Okay, let's comment this test completely out. This was our performance testing when we were putting in the binary search. Oops. Okay. And we'll clean out if we need to. Okay, but check the tests. Yeah, I think the async thing would be pretty easy, right? It should just be start up the app, throw off an async call to do our searching, and then check to make sure you're done before you use it. Yeah. Or doing a wait. Good. I don't think that was 0.001 seconds. And this should be fine. Let's find some words. Cells. Okay, and mower. Okay. All right. So, I mean, appears to be working fine. Let me put a non-word in. Okay. I don't know what's going on up here though. Bump something somewhere. All right, I think that's good. All right, let's do the run again. Oh, I should do a bear run from here. 5, 6, 7, 8, 9, 10. It wasn't that slow before. What's going on? We're not searching with it. Okay, that was pretty painful. All right, let's start from here so we don't have the Xcode overhead. Oh, I was gonna say that's how long it took before. Okay, what happened there? Okay, so maybe Xcode had some slow thing going on. Now this 2 through, yeah, that's about what it was before when we were just reading the dictionary and doing our full search. So, well, it's not a solid win yet, but I think we haven't tried. We are. Yeah, the simulator has changed. Oh, I'm building for 18.0. I think I had 18.1 on here. Oh, no, I guess I had 18.0. Okay. Thought I upgraded to another version. Well, I see more words on this one. No. Thought I saw no talent. Oh, a good thing I got 2 T's now. Okay. Yeah, that's okay. Have we changed the target OS? Oh, I did. You're right. I think. Let's see. Well, I'm saying deploy to 18.1. See if that makes any difference. I think the attaching is slow. But the actual startup seems okay. All right. I mean, so I think what we're seeing is the 2.5 seconds for reading the whole dictionary, turning it into a try, and that's that. Okay. Yeah, that's an idea. Is that in here? Where are those configurations? Can I do it here? Huh, betwist dictionary. And take those out of here. Sorry, I lost your schema. Oh, is that the test plan stuff? That shouldn't affect. Yeah, the letters, basically I have a list, so it's got like, 11 E's and 7 S's and 1 Z and it just, down on through the letters, and it just, for each spot, randomly picks one letter from that list. So it's weighted towards E, E, T, A, O, I, and S, sort of the traditional vowels and high frequency letters. And we know these, like this H and this H are both yellow because they're the same H, because the board repeats. It's a 5x5 repeating board. But yeah, the whole placement is random, and the actual, the letter choices across them is random. Okay. Well, I'm not so concerned because, well, I think this takes us to our next step, which is to run the dictionary converter and convert it to JSON directly, so we don't load this dictionary and then build the trie. We want to build the trie once and save it. Okay, so it's a little manual. Now, well, let's, okay, I don't know if I want to save these or not, actually. So right now we have vocabulary changed over to the new approach. What I think we want to do is let's open content view. All right, so we no longer have something that shows the list of all words. So I'm going to put that back on. Maybe in this board I got enough room to do it underneath this. Okay, so it's a text. No, it's a scroll view. Oh. So, I think I'm going to hold off on that. The only commented lines, right? Oh, these lines. Yeah, these. No, you're right. Those can go. That is nothing to do with. I thought I'd commented these out, but we do want to settle on what we're doing at some point. Okay. Okay, so back in content view, let's put a scroll view with text of game.all answers. I think that'll do it. No. Dot joined separator. And yeah. Okay. We'll see how quick that generates. 2.5. Now we're still waiting and waiting and waiting. Oh, that was an Xcode start though. But still, this is suspiciously slow. Okay. Let's try it. Oh, no, it came. Okay, well, there they all are. Lozenge. Hooted, wooted. Whoolighted. I don't know what that is. Ergotized. All right, that worked. Seems slow. Oh, that was. Wait, that was really fast. Let me do that again. Okay, so click that. 1001, 1002. Yeah. Okay, so it's kind of 2 seconds, but we know it's almost 2 seconds to do the other. Wow, cost juices. Is costumes in this list? Notice this all looks like, well, lots of words I never heard of, but the ones I've heard of seem good. Sanctum, and so on. It finds a lot of words. Like hundreds more than I do. I might have got tweak out of that. I don't know if I got wash, even knowing it's there, right? Vacuums, I thought I saw. In the long run, we're going to sort these, and I'm going to filter out anything that's short. I think I'm going to only show words that are 6 letters or bigger. Yeah, I mean, the dictionary I have is good, I think. Showcase. And some of the words, I look up and it's like, okay, that's a pretty good word. Swank, that's pretty good. Showcase, though, that's really good. I don't see it. S, H, where's O? Is it in there? Well, oh, I thought I had a, yeah. Worms. Okay. Well, where's showcases though? SH, oh, there it is. CHO. Wow. I don't know if I would have found that one. Pretty cool. And you get a few extra words for it. Well, a couple extra words. All right. Okay. Yeah, I think that's the strategy. That popped up in a couple seconds, 2-3 seconds from the legitimate start. Okay. 2.5, 3 seconds. Trothing, lithing, trithing, I don't know. Trothing is what you do in a wedding. Ogden, okay. Yeah, I mean, what I find is when I look the words up, they're really words. But yeah, I mean, it's finding more words. It finds more words I don't know than I find words I know. It's really amazing to me. I mean, maybe it's telling me how bad I am at this game, but yeah, that's building the tree and try and generating the list. So I think the fact that it's so fast to generate the try and come up with a search of those partial words, I think that says let's go ahead and get the JSON load done, and that should be good. I mean, I guess there's still an expense to loading it because the try, especially converted to JSON, is probably going to be 5 times as big as the dictionary. Because we got you got all the overhead of braces and spaces and everything else that goes in a JSON file, and fields and repeated field names, stuff like that. That does suggest I might want to get by with little tighter names. Is word next? That's tolerable. I could be okay. All right. So I don't think I'm going to take out vocabulary 2 just yet. But I think the signs are really good that we have a winner if it can do both, if it can do the load and the generate. One thing I will do, let's put something in here. Okay, I'm gonna pull this out. Builder equals that, and let's add a couple prints. So I want to know it built and it made. Okay, we don't. Okay, we have the words coming in. Okay, so this is have the words, however long it takes to print that, and then how long did it take you to actually turn that into a trie and then turn it into our new format. Okay, so let me run, and I'll stay over here this time. I don't know if it caches it while it writes it, though, but we'll see. Okay, so it looked to me like have words had a pause. So that was our making. That's good news because that means loading the words might have been pretty quick. I don't know if I can be more ready. Okay. Loaded to made seemed fairly quick. Yeah. Okay. That suggests that we are paying for building the words, which is not surprising. Okay, and that. All right. What do we got? All right. So what have we done? We switched to using a trie. And show all answers on main screen, and that's temporary. Yeah, it's returning it, but it has to walk the whole thing once to do it. I'm hoping the loaded is the slow one. Oh, I guess it doesn't matter. It's going to be more a question of how fast is the JSON. All right, now this is to where, I don't know, I seem to have lost I don't know why this went over there. Okay, so Swift JSON with recursive type. Okay, that's a Swift 2 answer. I'm not going to worry about that. That has nothing to do with JSON. Okay, Swift your JSON. For recursive type, you need a recursive method. Okay, that sounds like we need to do our own JSON. No, I don't think that's helping us. That sounds these shows are nested where they're not instances but are derived. Okay. Okay, and let's see. Let's just do this. I know Paul Hudson has a nice little guide for doing this. I think we looked at that one. That was all right. And this one was all right. That's the one. Okay, so I got to make him codable. Can I do that on classes? Yeah, the funny thing to this well, is there I mean, I need to store it somehow, right? Is there a better way to do this than JSON to store the dictionary? I mean, Java has that sort of binary format. I didn't know Swift UI or Swift did. Well, maybe that's a good question. Swift. Yeah, I think I have to do Codable, don't I? Or make my own format, I guess, right? I could do. Yeah, no, it's definitely going to take more time to load than the vocabulary. But do I have another option for saving a data structure like this? Or I mean, oh, but then I'm paying that 2.5 seconds. I don't want to pay, but it does make me wonder if there's a faster. I mean, I've used these low-level encodings before, you know, that they store unintelligible bytes of stuff, basically. Would that be better? I mean, yeah, I don't know how long to deserialize. I guess that's the thing I want to find out. All right, so let's get caught up here. I mean, we certainly could do the thread. Yeah, I don't get the feeling it does because of the recursion. No. So I don't know if I got to get a custom. Oh, hierarchical data. Oh, but that's not recursive. This is not. Well, let's make sure. If I add Codable to this, he's going to complain. So he's not going to do it automatically. Init from with decodable cannot automatically synthesize because character trie does not conform to decodable. Well, that's probably fixable. Yeah, but arbitrary depth is kind of a tough thing to overcome. Let's make a type for this. This is. Oh, let's see. What did it complain about? Character array of character trie. Okay. So struct try match. We'd like it to be codable. Cannot synthesize because array of character trie. Oh, let's make this just one. No, the decodable stuff really doesn't care about the functions. I mean, I'll have to fix the types up and stuff, but. Okay. I don't know if it'll deal with the recursion. Character does not conform to decodable. What? Character is not decodable? Cannot. Wow. Wow. Well, how is character not convertible? Is string Do I have to make it a string? No. Seems like they should have done the work. Thank you. Good question. Well, yeah, that kind of sucks. Can I do this? Extension Codable. Well, that's kind of what. I mean, it's not unreasonable. If you do your own public init with the decoder. Okay. And my other fallback was to change it into bytes because I'm just using letters. Oh, that's progress. That's codable now. What's the matter here? Cannot simplifies because character. Oh, I didn't use it. Then I got to figure out what I'm breaking. Try match dot character. Okay. Who are you next? Character tree. Okay. Make list should produce array of try match. Nope. What's going on? Well, character tree, this is a try match. Cannot convert character try to closest match try match. Okay. Protobuf. I don't know that one. Okay, so I think this is building now. I'm kind of surprised. I'm really surprised by the reason. Okay, no, there we go. Oh, every test. Well, these all have to be try matches then. Which isn't so terrible. Well, that's actually, I would say, an improvement. What did I miss? Oh, try match. Okay, who else? Yeah, it's definitely more clear. I mean, I'm not super thrilled with that navigating through down all those levels to do it, but it is what those tests are testing, is walking through the tree structure, and that's not unbelievable. All right. Yeah, I mean, it doesn't get through the what do you call that, train wreck, when you have dot 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 this dot that dot the other. Okay, I'm gonna keep that. So we're gonna make our try Codable. Okay, now we want our TrieNode to be convertible too. So let's make a TrieNode match. It looks a lot like this. Okay. Self.next equals next. Oh, this has to be TrieNode match. TrieNode match does not conform to decodable. TrieNode does not conform. TrieNode. Don't know if I'm killing. Okay, that made that better. Okay, this was .char. Arguments to generic parameter element in try. What's his? Has a try match. Oh, make list needs to produce try match nodes. for TrieNode matches. Siege. Well, let's see. There's probably some tests that don't like this change. But maybe not. We were testing at a pretty high level as far as matching and stuff. Okay. Okay, so we made TrieNode Codable 2. I suppose I should be expressing this on here as we go. Make try and TrieNode be codable. And then we're going to write the JSON for a try one time. Okay. Just that. Good. All right, now I know one of these examples had I just decode this from JSON. So we have to get the data from a file. Somebody's going to have a better example. I'm going to have to keep an eye on that protobuf thing. Now, data. Well, let's just look for an example. I guess we got to do the write first. So that's kind of what we'll do there. Ugh. Okay. I think I'm not going to have any time to do that since there's only a minute left. All right. But we can, when we create the TrieBuilder, I guess somewhere we're going to have to put a call to like TrieBuilder.make, and after we do that, put a write in. Okay. Yeah, for tomorrow. All right, but I think this is good. The try, it's potentially very fast. I mean, it seemed like the word list part was taking nothing added to the challenge of creating the try in the first place. It's nice. I mean, the binary search is not a bad thing, but the try is pretty tight. I mean, it's just a little loop. No, not the writing. This stuff. It's just doing this little loop, walking through each character and walking down that tree. That seems pretty good. I mean, it ought to be fast. Okay, so tomorrow we'll write this thing out and read it back in and see if we can make that go. All right, and thanks for joining today. Couple people haven't popped in that I haven't seen for a while or new. Appreciate you being here, and we'll be back 2 to 4:30 tomorrow, or 7 to 9:30. That's Eastern Time, US, or 7 to 9:30 p.m. UTC. Thanks again. Have a good night. Bye-bye.